Hi, welcome to solveandgo.com. In the next video, I'm going to give a fourth example of using the definition of the derivative to get the derivative of the sine function. This example is going to be a little bit harder. So we want to use the fact that the limit as t goes to 0 of cos of t minus 1 divided by t is 0. So this is a fact about limits. It can be proved using the squeeze theorem. We won't prove it here. But we're going to use this fact to show, using the definition of the derivative, that the derivative of sine of x is cosine of x. Okay. Let's apply the definition of the derivative. We have that if f of x is sine x, then the limit as h goes to 0 of f of x plus h. Okay, so let me describe what we're doing here. So we're getting the derivative using this limit definition. So this equals the limit as h goes to 0, f of x plus h minus f of x over h. Okay, so what we want to do here, we're going to plug in our function sine of x. We get sine of x plus h minus sine of x divided by h. Now, we want to deal, again, if we plug h equals 0 in, what you see is we get 0 over 0. So we want to change this expression. And the one way we can do that is by using the sum formula for sine. Okay, the sine of the sum of two angles. Okay, and what that formula says, you can look this up in any textbook, is that sine of x plus h is sine x cos h plus cos x sine h. Okay, and then we have, let me write this down here, minus sine of x. Okay, and all of this is being divided by h. Okay, so let me erase what's up top here. And what we want to do is rearrange this expression. Now, we were told to use a formula, a limit formula involving cosine, and what we also see is that we have a common factor of sine. Not there. It is sine of x and sine of x. So a common factor of sine here and here. Okay, so we're going to rearrange our limit to look like this. Okay, so we factor out a sine of x in this common term. Then what's left is cos of h minus 1. Okay, that gets divided by h. So this is 1. These two terms combined. And then we have this term here plus cos x sine h divided by h. Okay. So what we get here is the limit as h goes to 0 of, let me erase what's down below. This expression here, as we saw from the fact given, goes to 0. Okay, cos of h minus 1 over h, the limit as h goes to 0 goes to 0. So we get 0 plus cos x times sine h over h. Okay, now we need one more fact. Okay, we also have the fact that this is similar to the one given at the beginning of the video, the limit as h goes to 0 of sine of h over h is 1. Okay, again, this is a fact about limits that you can prove using the squeeze theorem. Okay, so then applying this fact, finally what we get is the limit. So let's factor out this cos of x. It doesn't involve h, so we can factor it outside of this limit, times the limit as h goes to 0 of sine of h over h, okay, which we know from below is 1, and so finally we get cos of x. Okay, so let me just recall the two facts that we used to prove. So what have we proven? We've proven that d by dx of sine of x is cos x, and the facts about limits that we used, these are worthwhile memorizing. The limit, as we'll call it t, just to make the variable general, of cos of t minus 1 over t is 0. And we also have that the limit as t goes to 0 of sine of t divided by t is 1. Okay, and again, what we've shown is this.